Hello all. So let us start with a problem for today's class. So the question is, so let x equal to the set 1, 2, 3 etc. n, where n belongs to n. Show that the number of R combinations of x which contain no consecutive integers is given by n minus r plus 1 CR, where we have 0 less than or equal to r less than or equal to n minus r plus 1. So here we are given the set x equal to the set 1, 2, 3 etc. n. Now we need to form R combinations from the set x such that it contains no consecutive integers. So here what we do is, so we will form a bijection between this R combinations and a binary sequence. Now using that binary sequence, we will find out the required number of R combinations. So let us define a bijection. So we first establish, so let us see the solution. So we first establish a bijection between set of all such R combinations of R combinations of x and the set of all binary sequences of length n containing R ones and n zeros. So containing R ones, that is enough. So obviously the remaining are going to be 0. So R ones such that there is at least a 0 between any two ones. So this is the bijection we are going to form. So between the set of all R combinations of x, so we will form a bijection with the set of all binary sequences. So the set is such that it's a binary sequence of length n and there will be exactly R ones. So we R combinations are R ones are, and the speciality of the binary sequence is that there is at least a 0 between any two ones. So there is at least a 0. So there is at least a 0 between any two ones. Okay, so let us write down it as a function. So define f from a to b as follows. So given an R combination, say if you have an R combination K1, K2, etc. kr. So these are numbers between 1 to n such that they are not consecutive of x, where you have 1 less than or equal to k1, so that is strictly less than k2, so on k3, so on kr, so that can be less than or equal to n. So let f of s be equal to b1, b2, etc. bn. So s is the R combination which is of the form k1, k2, kr. So f of s, so the corresponding to the value s. So we will get the function value as b1, b2, bn, and here bi is such that, so bi is 1 when I equal to k1, k2, etc. kr, and it is 0 otherwise. So let us see for an example how does this, so what does this bijection mean. Okay, so let me take, so for example, so let n equal to 8 and suppose r is equal to 3. So we are having the set 1, 2, 3, etc. 8. From this set of 8 elements we have to form 3 combinations. അപ്പോൾ 3 combinations എടുക്കുമ്പോൾ അതിൻ്റെ പ്രത്യേകത ഇതാണ്, കോൺസിക്യൂട്ടീവ് ആവാൻ പാടില്ല. So let me take 3 combinations. So I can take 2, 4 and 6. അതുപോലെ I can take 1, 3 and 5, and so I can take 1, 3 and 8. Okay, now none of these are consecutive. Now let us define what is f of 2, 4, 6. So this is how we have defined f of s. Of s in the value b1, b2, bn. So whenever I is equal to k1, k2, etc. kr, b1 will take the value 1 and it will be 0 otherwise. So let us take the value. Okay, let us look at what is the value of b1. Okay, so here if we look at the first entry, so first entry does not belong to this set. അപ്പോൾ നമ്മുടെ k1 എന്ന് പറയുന്നത് 1 അല്ല, so 1 is not there. അപ്പം 1ൻ്റെ പൊസിഷനിൽ 0 ആയിരിക്കും വരിക. ഇനി I can take this as k2. Okay, so when I is equal to, so 2 is there, അപ്പം 2 ആ സെറ്റിലുണ്ട്. സോ 2ൻ്റെ പ്ലേസിൽ 1 വരും. ഇനി 3 ഉണ്ടോ എന്ന് നോക്കുക. 3 ഉണ്ടെങ്കിൽ 3യുടെ പ്ലേസിൽ തേർഡ് പൊസിഷനിൽ 0 ആയിരിക്കും വരിക, ആൻഡ് 3 ഇല്ലെങ്കിൽ തേർഡ് പൊസിഷനിൽ 3 ഇല്ലെങ്കിൽ 0 ആയിരിക്കും വരിക. 3 ഉണ്ടെങ്കിൽ 1 ആയിരിക്കും വരിക. അപ്പോൾ ഇൻ ദ തേർഡ് പൊസിഷൻ 3 ഈസ് നോട്ട് ദെയർ, അപ്പോൾ 0 ആയിരിക്കും വരിക. ഫോർത്ത് പൊസിഷൻ, സോ ഫോർത്ത് പൊസിഷൻ 4 ഉണ്ടെങ്കിൽ 1 വരും, 4 ഇല്ലെങ്കിൽ 0 വരും. 4 is there. In the fifth position 5 is not there, അപ്പം ഫിഫ്ത്ത് പൊസിഷനിൽ 0 ആയിരിക്കും വരിക. Then 6 is there, so 1 will come, and 7 and 8 are not there. Okay, so you can see that consecutive അല്ലാത്തത് കൊണ്ട് 1ൻ്റെ ഇടയ്ക്ക് എപ്പോഴും zeros ഉണ്ടാവും. There will be at least one 0 between 2 ones. Now let us look at what is the value corresponding to 135. So corresponding to 135, 1 is there, first position 1 varum, 2 is not there, 0, 3 is there, 1, 4 is not there, 0, 5 is there, so 1, 6, 7 and 8 are not there, so 0 varum. Now let me write f of 138. So that will be equal to 1 is there, at the place 1 varum, then you have 0, then you have 1, then 4 is not there, 5 is not there, 6 is not there, 7 is not there, then you have 8. And now if you look at this type of sequence, you can see that the sequence exactly contains 3 ones, and between the ones there will be at least 1 0. Ini starting positionilum ending positionilum 1 varadirikka. Okay, so it can start with either a 0 or either a 1. Now this can be considered in the like a distribution problem. Okay, here you can consider it as say 4 boxes. So this can be considered as the object in the first box, then objects in the second box, third box and fourth box. Okay, from here first box, second box, third box and fourth box. First, second, third, fourth. Okay, so here you have box 1, box 2, box 3, box 4. Now നമ്മൾ ഡിസ്ട്രിബ്യൂഷൻ ആയിട്ട് ഇത് എടുക്കുമ്പോൾ നമുക്ക് കാണാൻ പറ്റും സെക്കൻഡ് ആൻഡ് 4 ബോക്സസ് ഉണ്ട് ഇവിടെ മൊത്തം. സോ 4 ബോക്സസിലായിട്ട് നമുക്ക് 5 ഓബ്ജക്ട്സ് അറേഞ്ച് ചെയ്യണം. സോ if r is equal to whatever is r, so the number of boxes are going to be r plus 1. So you have r plus 1 boxes, and you need to distribute n minus r identical objects. Okay, ini nammal arrange cheyyumbom you can see that between ones there will be always elements. appo ee box eppozhum non empty aayirikkum, idum non empty aayirikkum, ni ivide empty avam, empty alladirikkam. So we will find how many such distributions are possible. So using this we will count the number of binary sequences. Okay, so so we have, therefore cardinality of A will be equal to cardinality of B. Then we need to find now cardinality of B. So a binary sequence in B can be regarded, so we will write using boxes now. So it can be regarded as a way of distributing n minus r identical objects in r plus 1 distinct boxes, such that the second, third, etc. rth boxes are non-empty. So therefore we first put one object each in the boxes. അപ്പോൾ നോൺ എംറ്റി ആവേണ്ട ബോക്സസ് എല്ലാം 2 to r, and the remaining objects are distributed arbitrary. അപ്പോൾ റിമൈനിങ് ഓബ്ജക്ട്സ് നമുക്ക് ആർബിട്രറി ആയിട്ട് ഡിസ്ട്രിബ്യൂട്ട് ചെയ്യണം. സോ ദിസ് കെൻ ബി ഡൺ ഇൻ, അപ്പം ഐഡൻറ്റിക്കൽ ഓബ്ജക്ട്സ് ആയതുകൊണ്ട് ആദ്യത്തെ ഇടയ്ക്കുള്ള ബോക്സസിൽ പ്ലേസ് ചെയ്യുന്നത് ദാറ്റ് കെൻ ബി ഡൺ ഓൺലി ഇൻ സിംഗിൾ വേ. സോ റിമൈനിങ് n minus r minus r minus 1